Okay, once your Raspberry Pi is set up, we can go ahead and maybe do like our initial, I don't know, just an initial sort of test, get something working. This isn't actually any particular lab. It's just sort of showing you the workflow of working with the Pi. So let's go to idle 3. This is the one you always want to use. Never use Python 2. Okay, always use Python 3 because that's what we'll be working with. And for the most part in this course, until you reach the final project, we're going to be giving you code skeletons to work with. And by that I mean there will be some sort of code file which you'll be given. You don't have to write code from scratch. That being said, we kind of want you to work towards that eventually. So just keep that in mind. So I'm just going to go into idle. You saw I went up to File, Open, and I went and opened a Python file. And this Python file is called x1.py. And so Python's got two environments, as you've already been seeing. There is a file window over here. This is the actual Python script which you'll be writing, and then this is sort of the Python shell where it can execute and we can see outputs appear. So for example, right now, let's just look at most of this stuff we don't need. I'm going to delete it. All right, so this is a basic Python script talking with the Raspberry Pi. We import a GPIO library. We do some setup on the GPIO. Those can just stay at the top. Then what we do is we find a few pins that we like, and then we pick and set them up. So we say, okay, pin 13 is going to be an input, and we're going to set that as a pull-up input, which means it's by default high. And by high, we mean electrically high. So whenever it's not being pushed, it's going to be returning a binary true. All right, and whenever you push it, it'll be a false. And we'll set that up in a minute. Then we have two other pins. These are outputs, and we can use them to drive LEDs or like switches or any sort of thing we want to electrically manipulate. We set pins to be outputs. If we want to listen, we set them as inputs. So the first thing we can do is let's initialize. So we've set everything up. Let's say GPIO.output of 20 is a false, and let's say GPIO.output of 21 is a false. Okay, and actually let's go up and import time. All right, and we'll see what time. I mean, we're going to bring up time like 40 times in this class. Down here, because we have time, we're going to do time.sleep. We're going to sleep for 1 second. And I'm going to go GPIO.output of 20 is a true. I'm going to do time.sleep of 1 second. I'm going to do GPIO.output of 20 is a false. Okay, what'll this do when it runs? It's doing some stuff, and it's done. Okay, so nothing actually happened. That we could see. In real life, what happened was pin 20 went high, and then it went low. So let's actually attach an LED to our system so we can start looking at what happens like whenever we run this code. So here's an LED. All right, it's got a long leg and a short leg. All right, the short leg will always be going to ground in our setups, and the long leg will be going to usually the signal that we're interested in. Now, just with these wires on their own, if I go to 20, I'm going to put the long leg into it, and then I want the short leg to go to ground. Now, right now, what we can do, just as an example, we can put the short leg to the ground pin right here, and you can see that if we just so you can see the LED is got its long leg in pin 20 and its short leg in ground. Okay, great. So why don't we actually run this code again and see what happens? Because we ran it before, whatever, and it didn't do anything. Now let's run it. Okay. Okay, we can see actually the LED went on, which is really interesting. Okay, let's run it again one more time. I'll go over here and I'm going to press F5 in the Python script. Then it's running. It's on. Okay, interesting. All right, let's go through the code real quick. What did we do? So we started off, we created these two output pins. We then said, okay, pin 20 and 21, they're both false, which means they're both low. The outputs are both low. We slept for a second, just because. We then turned pin 20 to true, which means it was high. We waited for 1 second, and then we turned it to be low again. What would happen if we did the following? I'm going to copy paste those 3 lines of code, and instead of turning 20 on, I'm going to do 21 is on and turn it off. So what's this going to do? Think about it for a second. And in order to actually see that take effect, we're going to add a second LED into our system. Let's pick a red one, and I'm going to put this red one long leg to 21, short leg to ground. Okay. All right, let's run this, see what it does. Okay, interesting. If we go through what happened, again, start them both low, wait a second, turn one high, wait a second, turn the first one low, immediately turn the other one high, wait a second, and then turn it off again. So can we make this, so this is nice, it ran once through and it was all done. Can we make this like run forever, for example? Could we have the thing like flash continuously, let's say, for example? Why don't we try that? So we can do that in a loop. So let's do while true. All right, I'm going to highlight all of this. Let's indent the region, as you just saw. I highlighted it. All right. So what will this do? I mean, and I know I'm throwing a lot at you for this, like one of these initial videos, and we'll be going over all these little pieces lots of times again and again and again. But all we're doing is now we're going to have this same chunk of code that we had before, and we put it in a while true loop, which means run this code while true equals true. What this is really saying is while true equals true. So while true evaluates to true, which by definition it sounds really stupid, but that's always true. So that's always, always, always going to be running. So basically it's going to sleep for a second, turn something on, wait a second, turn it off, immediately turn the other on, wait a second, turn that other thing off, sleep for a second. So it's going to look kind of interesting. Let's see what it does. Okay, interesting. Let's kill this code. I'm going to do that by pressing Control-C. All right. Now that's not really the best way to do it. Do you see this red text that showed up? That usually means things are sad, kind of. So what we're going to be doing almost all the time in our class is putting this stuff in sort of a try, except setup. So it's going to be try. This piece of code goes in it, inside of the try. So we do that by indenting it one more. And then we're going to put except keyboard interrupt. All right, and then they do gpio.cleanup, which just sort of makes sure all the pins are low and happy and everything. Okay. Now that was cool. Let's change it one more thing. I don't like how slow it's going. So what I'm going to do is, first of all, I'm going to get rid of this first time.sleep because it actually, when this is on, when it's sleeping, both pins are off. So it's kind of a boring part. So we're going to get rid of this. Then let's make this 0.1. Whoops. 0.1, and let's make this 0.1. Okay? Now what's going to happen? It's going to run much faster and probably not have any time point when the LEDs are not, at least one of the LEDs will always be on, is what I'm saying. Okay, let's run it. Okay, good. That would induce a seizure if necessary. Okay, look at that. Back and forth, back and forth. Okay, so back and forth, 0.1 seconds. Let's change this again. Let's control, oh, this is a good demonstration of the Control-C now. Okay, do you see how nothing bad happened? I pressed Control-C too many times, that's where that came from. But because I had the try except thing right here, which is what I always want you to be putting your code in, we could exit it really quickly. Let's make this code a little bit faster. Let's make it 0.01 and 0.01. We save it, Control-S, and run it again, F5. What do we get? Okay, we actually can't even tell. You can just barely maybe sense, because of the frame capture rate of the camera, those two things flashing on and off. My eyes, though, I actually really can't see when I'm looking at it directly. So why don't we lower it. I'd like to get it to a high enough rate, but something which we can't really detect. Now, you can see right here, there's two things I'm changing. So this one and this one. This is a key spot, a useful spot in code where you maybe want to use a variable. So why don't we add in a variable name called pause in both spots? And then what that means is later on, so now I can just specify what pause is up here. So maybe 0.05. Let's do that instead. And then in the future, if I want to change this, the time period through the loop, I just have to change one line rather than two. So anytime you're programming and you're finding yourself having to do, and you're debugging and changing things, and when you want to change one thing, you have to change it in 9 spots, that's a key moment when you should realize, oh, I should be using a variable. So if we run this again, okay, faster than before, very nice. Cool, okay. So that's outputs. Can we do something now with inputs? So in the first couple labs, we're going to be using these things called switches, and they look like this right here. All right, if I zoom out a little bit, so the switch has 4 legs on it, and if you look at the data at the lab very, very carefully, there's actually one good way to put it in, one bad way. This is a good way. This is a really bad way. So don't do it this way, okay? The switch is basically useless when it's like this. You can have the switch like this or like this. If I can get that in there, good. Okay, but not like the other way. Now, how do we use the switch? So if you look at lab 2, what we want to do is we want to have one side of the switch going to a resistor. I'm sorry. If you look at this thing, what we want to do is we want to have one side of the switch going to ground. So I'm going to do that with a wire. Now, where do I actually put this wire? That's what gets confusing. And so this is a good point to actually pause and let's plan ahead in our wiring. So now if we go to the top of the Pi output right here, you can see there's this 3v3 pin. If I look directly above, and always try to be looking directly above because it's actually really, if you look at it this way, pins look like they're in the wrong row. So looking at it directly above, 3v3 and GND. What I want to do is I want to take a short wire and jump this 3v3 row to the red row right here, and then that means the entire red row all the way down here is going to be 3.3 volts, which is one of the most widely used voltages we'll use. And we're going to take a wire and jump from here to here, okay? Same thing up here, we're going to take a wire, jump from the ground to the blue, and then that means this entire blue connector is ground, and then we're going to jump to this blue. Alternatively, we can do those 2 jumpers, and then on the other side of the board, there should be a 3-3 connector. No, there isn't actually. But you can use one of these ground pins over to here. So I'm going to do that right now. And so I'm going to take some short wires. Maybe a yellow one. Doesn't really matter. Well, short wires are nicer because they keep your circuits clean. I'm not going to stop you, but it would be good to keep them short, or as short as needed as possible. So I'm going to take a yellow wire and connect it here like that. Okay? Now you can see 3.3 volts is going to the red rail. We call that a rail whenever it's a really long connection. And then ground, I'm going to have that go to here. Actually, I'm going to move that here. Okay, so then if we look at it from directly above, you can see this is very nice. 3.3 volts going here, and ground going to blue. Then what we're going to do is down at the bottom, just for convenience sake, I'm going to take a red wire and jump from one red rail to another. I'm going to take another red wire and jump from this blue rail to this blue rail. And this is great because now we have 3.3 volts on both sides of the board, easily accessible, and ground, the 0 volt line, accessible on both sides of the board. So this is good moving forward. You should do this in like the first hardware lab and just always keep it that way. So now when I build my switch, so again, we ran into the conundrum where maybe we didn't have room to wire it. So if we go into our switch now, what I'm going to do is I'm going to take one side of the switch and wire it to ground like this. Okay, that might be actually a little bit short of a wire for my taste. I'm going to actually get a yellow wire. I'm going to put it like this. And pay attention to where these wires are going, okay? This is not, you know, if you're one row off, it's wrong. Like, there is no shade of gray in some sense here, okay? And then let's take another wire. And I want to, if we go back to our code, we can see that I had actually said, okay, I'm going to have pin 13 be my input. So where's pin 13 on this board? It's actually right here. I'm going to look directly above it, make sure I can see it. And now with these switches, I could put the yellow wire on this side, or I could put it on this side. It actually doesn't matter, okay? Both sides are connected when you have it hooked up this way. If I put it here, it's actually a completely useless switch, okay? Like, pushing it won't matter. So I'm going to just, you know, put it here for right now. Good. Now, how do we actually get that switch reading? All right, so whenever I'm pushing it, I'm actually putting in, so this switch is normally on, and when I push it, it's actually giving a 0 reading to the pi. So why don't we do the following? So let's go back to our code, and while true equals true, oh, that's stupid. All right, so while true, let's check. So if GPIO.input of 13 equals true, and you can see I did a double equal, okay? Then we'll do this weird timing thing, okay? So I'm going to do format indent region. All right, what do you think this will do? Let's give it a shot. I zoom out a little bit. Oops. Interesting. Okay, if I push this, nothing. Oh. Okay. Why is it doing that? If we go to the code, so all of the code you'll be writing with the Pi, almost all of it in this course, is going to be built around these loops, okay? The Pi almost, we think of it, basically it's always on guard. It's always running a set of code again and again and again and again, and it's doing it very, very, very fast, all right? So many, many times a second, and we're talking thousands of times a second, it goes through and it checks if the switch is true, all right? And true corresponds to when the switch is not pushed as we have it hooked up, okay? If the switch is not pushed, if it's true, do our LED on, wait, LED off thing, okay? It's just going to do that. If the true switch is pushed, it's actually not going to do that, okay? So a real quick thing we could do just to modify on this, let's do if, how do we want to do this? Let's do it so that the pin 21 switch is on, or the 21 LED is on when the switch is not pushed, and then the 20 LED is on when the switch is pushed. So let's do, if we're not pushed, 21 is true, 20 is false, else, and let's just copy paste real quick. Whoops, that, oh god. Okay, and let's flip these. All right, let's see what this does. Okay. Nice. And of course, I could have flipped that if I wanted to. So hopefully this gives you a little bit of an example of like just how to work with the breadboard. Okay, it's very tough to, you know, this stuff is not gonna, you can break stuff, but it's hard to break it. Okay, so don't be afraid to just get in and mess and hook up wires. So real quick, you can see how I wire this up, just so there's no confusion. All right, yay, push the button. Awesome. Okay.